Hi, everybody. This is section 6.3. Very similar to 6.2. So I want to go back up to 6.2 just to show you really quick. I want to go back up. And I want to show you the formula. I do. This is the formula we used. Z equals X minus the average divided by standard deviation. All right, so I just wanted to re-show that. And now I come back down and read one of these questions really quick. Each month, an American household generates an average of 28 pounds of newspaper garbage. Assumed variables are approximately normally distributed and standard deviation is 2 pounds. If the household is selected at random, find the probability of generating between 27 and 31. What we did last time was find the Z values, then plug it in our calculator, the lower and the upper, and find the area that's shaded in between those two lines. So it's important because when you read this question, the next section that we're covering will look very similar. 6.3 is the same thing. By the way, don't even worry about reading. You can read through this first part. We're not going to cover any of this first part. But here is the formula we're using for 6.3. This is 6.3's formula. Let me write down 6.2's formula again. Z equals X minus the average over the standard deviation. So they use this X bar, but that's just, it should be X. Okay. Do you see it looks the same, except on the bottom, they have the square root of n in the 6.3 formula. So the hardest part about this section is knowing which formula to use on the test, because they're not going to tell you, oh, use the 6.3 formula, don't use the 6.2. So 6.3 formula is used when the paragraph states that you were dealing with a sample. Okay, 6.3 formula is used when we're dealing with something that's called a sample. When I drew a sample, 50 people were selected. Once again, X is our value, mu is our average, our mean. Here's our standard deviation, and n is the number of people being sampled. How many people or how many items are being sampled, okay? So this is our formula we're using for 6.3 when they talk about a sample, okay? I'm going to erase this now. This looks really messy. Okay. So let's take a look. Same type of scenario as yesterday. We read the paragraph, we answer the question. They have the picture for us. But pictures won't always be there. A Nielsen reported that children between the ages of 2 and 5 watch an average of 25. So there's our average, our mean. Assume the variable is normally distributed and standard deviation is 3. Standard deviation is 3. If 20 children are randomly selected, n equals 20, that's a sample. When they say we're going to just look at or talk to 20 children, that's our sample. So we know to use this formula. We know to use this formula here because we're dealing with the sample. Find the probability that the mean number of hours they watch TV is greater than 26.3. Greater than 26.3 is everything shaded in this way. So we need this Z value, And we need this z value. The z value on the far right is a positive 99, positive infinity. We just have to find this z value here. That'll be our lower, and this will be our upper. We're going to use, to find that z value, we're going to use our formula up here. Our value, which is 26.3, this is our x value, minus our average. Our average was 25. There's our mean, or average, divided by the standard deviation, which is 3, divided by the square root of 20. So I say put the top in parentheses, put the bottom in parentheses when you type that into your calculator, or you could get it wrong. So let's try this on our calculator. All right, I have my calculator here. Let's type it up. We're typing in parentheses 26.3 minus 25, close parentheses, divided by parentheses 3 divided by the square root of 20. I'm going to arrow out to get out of the parentheses, and get out of the square root and then hit parentheses. I don't want to put the parentheses inside the square root. I wanted to arrow over and get out of it. Now when I hit enter, it should give me a z value. Hopefully somebody here gets the same z value as I do. I got a z value of 1.937. Remember, z values go 2 decimal places. So my z value is 1.94. So this z value is 1.94. So we're using the lower as 1.94 and the upper as 99. So don't forget, we have to use our calculator to do this, and to find the area, you have to do second vars, number 2, which is, let me look at number 2 again. Second vars, number 2, normal CDF. Hang on, I messed this all up. There we go. Second vars, normal CDF. And then we're going to do the lower, which is the left side, and the upper, which is the right side. The lower, which is 1.94, 1.94. And the upper, we're putting infinity, which is 99 standard deviations. Hit enter. What happened there? Yeah. Hit enter, 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 enter. And it gives you the area. You see it's a very small area here. So the area that's shaded in, an area is shaded in is always the 4 decimal places, 0.02618. 18, which rounds to 4 decimal places, 262. So there's the area that's shaded. We use the other formula when we have a sample, when we're taking a specific number of people and surveying them. If you read the 6.2 assignment, there wasn't a specific number of people. So that's when we use 6.3. All right, everybody okay with that? We'll do a few more of these, and this is it. If I remember right, this should be it. Let's try again. The average vehicle registration in the United States is 8 years. We're doing this in months, I guess. And remember, it says the average, so that's our mean. Yeah, there it is right there. Our mean is 96. 96 months. Our mean is 96. Our average is 96. Standard deviation is 16 months. A random sample, as soon as they say sample, 36. N equals 36. We're randomly sampling 36 people. So we know we need to use Z equals X minus the average over standard deviation divided by the square root of N. We're going to put the top in parentheses, and we're going to put the bottom in parentheses. All right, so we need to find two Z values here. We have to find this Z value, and we have to find this Z value. The first one, Z equals the X value. Don't forget, this is the X value. X minus the average. The average was 96 divided by standard deviation over the square root of N, and N is 36. Wait, what are something went, why did I put X there? There should have been the value. The value was 90. Right, there's the value right there. There's 90, there's the average. So it should be 90, 90, 90 minus 96. And then we're going to do the second one. The second one, Z value is the value is 100 minus the average. The average is 96 divided by standard deviation divided by the square root of N. All right, so let's put both of these in our calculator. Parentheses. First one, 90 minus 96, close parentheses, divided by parentheses 16 divided by the square root of 36. I arrow out of the square root, and then I put my parentheses. And when I hit enter, I get a Z value of negative 2.25. So there's the first Z value, and sure enough, it's on the left so of the mean, so it should be negative. So let's try the next one. This is the Z low value, or 1. This is the Z high value, or the second one. The value, once again, parentheses, 100 minus 96, close parentheses, divided by parentheses 16 divided by the square root of 36, and I arrow over. Now I'm out of the square root, and I can hit my close parentheses, and I get a positive Z value of 1.5. So this Z value low equaled negative 2.25. This Z value high equaled 1.5. This is the low, and the high I put in my calculator. I know now go to second vars, number 2, PDF, norm, dist, PDF, CDF, I'm sorry. Second vars, normal CDF, normal CDF, sorry, CDF number 2. And the low, we ended up with negative 2.25, negative 2.25. And the higher one, the far right, was 1.5. And this should tell us the area that's shaded in. The average and the standard deviation should always be 0 and 1. And so the amount of graph shaded in to 4 decimal places is 0.92096. 4 decimal places is 0.9210. 9 changes to 10. So this is the area that's shaded in, 0.9210. That is the answer. All right. Same as yesterday. We just have the little square root of n to add into everything. That's it. And we know, and by the way, on the test, it's not going to tell you which formula you use. You know, when you have a sample, you have to do, if you have a sample, you have to use the sample formula. The average time spent on construction work is this. That's the average, once again, and it tells you the average dead center. That's the average. Assume the distribution is normal, standard deviation of 0.8. Find the probability an individual who works at that trade works fewer than 8 hours. So we have to find this z value, and we have to find this z value. Well, this z value is negative infinity, so this z value is negative 99. I already know that one. Negative infinity is negative 99. I just have to find this other one. Now, in 615, in this problem, did they tell us a sample? Was there, how many people were surveyed? Do you see, in this problem, it didn't tell us how many people were surveyed. So since it, then this one, this is not a sample, because they didn't say we're doing 40 people. Like down below, the next question, if a sample of 40, so down below is the same question, but they're talking about a sample. The problem we did is not a sample. Since it's not a sample, to find the z value, we're just using this. We're not using the square root of n because it didn't tell us what n was. You see, it's not a sample. So we're going to find the z value. The x value is 8. The average is 7.93. There's our average. Divided by our standard deviation in the paragraph, it says 0.8. So my z value is 8 minus 7.93. I hit enter and then divide. So in this case, you can put a parenthesis around the top and then divide it by 0.08, or you hit enter and then divide it 0.8. Did I say divided by 0.8? No. So it's 8 minus 7.93. Hit enter, divide it by 0.8. And I get a very small z value of 0.0875. 0.0875. Z values always go to 2 decimal places. 0.09. So this rounds to 0.09 because the third decimal is 5 or more. So the second decimal goes up to 9. So I'm going to put this in my calculator. Here's my lower. Here's my upper. Second vars. Number 2, lower was negative 99. The upper was 0.09. Enter, 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 enter. And there's the percentage that's shaded in. It should be more than 50%. You see it's more than half. And it's 0.53. I can't see. 0.53585. 53585. 4 decimal places is 0.5359. There's the answer. That's the part that's shaded in. Okay. So let's go to the next one. So you got to be careful when you read it. This is not a sample, so I don't use the sample one. I use the 6.2 formula. Now this one, it says, do you see everything's the same? Except we have a sample of 40 workers, so n equals 40. So we use z equals x minus the average over the standard deviation divided by the square root of n. Z equals x, x is 8. We're trying to find this z value here. We already know this one is negative 99. 8 minus the average. The average was 7.93. The average is the middle piece there. Divided by the standard deviation. The standard deviation was up above. What was the standard deviation? I can't even read it. Where was it? 0.8. So standard deviation is, oh, what happened? There we go. Standard deviation is 0.8 divided by the square root of 40. N is 40. So we put this into our calculator. Parentheses 8 minus 7.93, close parentheses, divided by parentheses 0.8 divided by the square root. That's not the square root, is it? What did I just push? Yes, the square root of 40. Arrow out of the square root and then close the parentheses, and I get 0.55. I get a z value of 0.55. 2 decimal places for the z value. 0.55. So there's my lower, there's my upper, second vars. Number 2, normal CDF, second vars. Number 2, negative 99 is my left side, lower, and 0.55 is my right side. Hit enter, and I get 0.7088. 4 decimal places, 0.7088. So that's the portion that was shaded. All right. So if you see the sample, you use the 6.3 formula. If you don't see a sample or the number of people surveyed, then you use the 6.2 formula. And the rest of this is not on the test, not on the final. Don't worry about these. Oh, do not worry about these standard error formulas. No, no, no. And that is section 6.3.